Hello, my name is Daniel Crook. I'm a developer advocate at IBM, focusing on serverless architectures with Apache OpenWhisk, which powers the Cloud Functions service on IBM Bluemix. In a recent proof of concept with a large global bank, we modernized a check deposit workflow using OpenWhisk in a hybrid model, with part of the application hosted on IBM Bluemix and the other running on premises. We built a system that auto-scales in response to payday deposit demand, which spikes every 2 weeks. The public-facing part of the application handles check image upload and resizing, then securely transmits data for optical character recognition and transaction processing on-prem. Processing check deposits is a great fit for a serverless architecture. This workload is highly variable, meaning that it can be extremely inefficient to pre-provision a set of computing resources in anticipation of just that peak demand. While the idle capacity ensures that the job can be done, it leads to a lot of wasted capacity during times of low demand. Furthermore, scanning checks for data using optical character recognition can be a compute-intensive task, which may take capacity away from other applications co-located on the same, mostly idle hardware to improve overall utilization. While the use of checks may be on its way out, it's still a core banking service in demand by millions of customers in the United States, France, and elsewhere. And perhaps because it's considered a legacy business, it's one that's ripe to revisit with a highly cost-effective solution. All told, this customer proved that they might employ the solution to theoretically process 1 billion checks for only $32,000, assuming all Bluemix Cloud pricing, which would make it much cheaper than the compute costs of their existing system for that same workload, using a traditional virtual machine or bare metal approach. This proof of concept highlighted several key strengths of the OpenWhisk serverless platform. Actions, or functions, can be written in the best language for the job because of OpenWhisk support for polyglot development with Node.js and Docker, among other SDKs. The same OpenWhisk core system can be consumed on the public cloud and installed within your own data center. The open source nature of OpenWhisk makes it transparent how data moves through the system and is stored at rest. And OpenWhisk has built-in support for responding to database change events from Cloudant and Apache CouchDB. While the sample code leaves out the custom features built for this particular customer, including the split between the public and private instances of OpenWhisk, for simplicity, the main concepts and the core of the workflow should help you understand how to build your own similar system. The first thing we'll do is log into Bluemix and provision the data services needed by the proof of concept. So first, we'll set up Cloudant, our database as a service, give it a name of Cloudant-OpenChecks, create the service, and now we'll go create the object storage service. We'll select the Bluemix object storage based on Swift. Create an instance. Let's give it a name of object storage-OpenChecks and create that and wait for it to provision. Okay, we've got our two services provisioned. Okay, now let's go and configure the Cloudant databases. We'll open the service, launch the console, and go ahead and create the 5 databases we'll need for our application. Okay, Well, we've created our 5 databases. Now let's go configure our object storage service. We're going to create a single container in here, and we'll name that OpenChecks. Now we'll go set up the cloud and credentials. We need to generate a set of credentials, which we'll use and store in a properties file later. And we'll do the same for object storage. Again, go to the Service Credentials tab in the left nav and generate those credentials. Okay, so copy those credentials and we'll put them in a new properties file. So let's clone template.local.env to local.env. Git ignore will make sure that this doesn't go back into a repo. And we'll set the cloud username and password, as well as the object storage details. And I won't show it here, but you'll also need SendGrid and Docker Hub credentials set. Now we can move on to looking at this convenient script that we use to set up our triggers, actions, and rules. It's got a bunch of functions in it. One is the install script, which will use the local.env file to configure the cloud package, the triggers for all the data changes. It'll set up our package to associate variables with for our actions. We create the actions, build the Docker action, and enable the rules that map the triggers to the actions. And this also has an uninstall script in it as well, and we can echo out environment variables for debugging. Okay, now that our script is ready, let's go back to the Bluemix dashboard in the functions area. Download the WSK CLI, which will be used by that deploy.sh script. There's 2 different options. You want the WSK CLI for this example. We'll download it for our platform and put it in our path. And we'll set our API key to use our credentials for this space. Okay, we should have an empty workspace now. Yep. So let's run that deployment script. Okay, we'll set the package, the triggers, create the actions, one of which needs a Docker build, and then map the triggers to the actions with the rules. And we can do whisk list again, and we'll see that all of our resources were set up there. We don't necessarily need to bind the cloud and package here because we're going to use it directly, but that could import the credentials for other types of applications. You'll see the credentials are now available to us as a package. Okay, so now that it's set up, let's give it a try. There's a bunch of sample check images in the repo. We're just going to use that. We're going to replace user@example.com with my actual email address so that I get notifications when the checks are processed. We'll do that for all 5 of them. Some are known to be good and some are known to be bad. That's why there's multiple. So let's go ahead to our object storage service and upload those 5 checks to the container we created. And before we do, actually, well, let's go make sure we're tailing the log so we can see those images get processed as they enter the container. So whisk activation poll. Okay. Let's upload those files to the container that we've set a trigger on. Okay, all 5 are there. And the polling trigger is going to fetch and download those checks. You can see it's going through the actions, and it is parsing out the data after resizing the images. And we can also see that processing happening in the Bluemix UI. We can look in the CLI log or check out the monitoring dashboard. All green is good. We can see how long code ran for, successful messages, and we can see that it was able to parse the check and pull out account details, the routing number, the deposit to account, and as well as the metadata from the check itself, the check image. And we also have a different view, the same thing that Whisk list gives us. We can see our set of actions, our sequences, our rules, and things like that. Okay, let's check our email to see if we've got any details. Good. We've got 3 success messages with the deposit information, the checking information. So we had 5 checks, and we've got 3 emails. So that means that these 3 succeeded and 2 did not. You can see that there's duplicates of the resized images. So we have 10 records. Here are successful processed deposits, and here are 2 rejected deposits. So it couldn't parse the image from account or routing information. Okay, and you can see the object storage has been cleared out because those checks were processed. And finally, we're going to just tear down our resources to make sure our workspace is clean. Okay, I hope that demo showed you how you could recreate this journey and create a serverless architecture for your own application, which might be similar to this compute-intensive variable workload, such as for check deposit handling. Thank you for watching, and feel free to reach out if you have any questions or if you'd like help with a similar proof of concept. Thanks.